Hello, dear aspirants. This is Dr. Saurabh Sir's class. We are solving our National Boards of Higher Mathematics previous year questions. So, this is from our year 2018. So, the question is telling us that let n greater than equals to 2 and our let W be the subspace of our MNR. That means MNR is what? That means this consists all the vector, all the matrices whose are of order R and with real entries. So our W is what? Is a subspace of that consisting of all matrices whose trace is 0. Okay, so now if our A is equals to bracket Aij, that means our A is equals to this and our B is equals to our Bij for I and J is running from A to N. Okay, our elements in M and R define their inner product by inner product of AB, yeah, that is my I, J is equals to 1 to N and this is my Aij, Bij. Okay, the usual form of inner product. So now we have to identify the subspace W orth of elements orthogonal to the subspace W. Okay, I think this is not so trickier question because we can do that in this manner. So firstly we are going to think about our 2 cross 2 matrices. That means let our n be 2 in particular. Then let our A be what? That is my A11, A12, A21 and A22. That will belong to what? That will belong to my W orth. So then our inner product of this is equals to 0 as for all B belongs to W. As A belongs to W orth, we all know that the inner product will be 0 when all belongs to W. Okay, yeah. So now I can do that. Now we can take, I want to write it and with another color, yeah. So take the following elements of W, that means the basis of W, that will look like what? I want to do the, no, we have the matrices whose trace are 0. So the matrices will look like what? A, B, C. Let 3 be the random entries from our real number set. And the fourth entry will be what? We have told that the trace is my 0. So the trace will be 0 when this thing will be my minus A. So we can write it in another form. If we take the common things out, we will get this thing and plus our this will be 0 1 0 0 and plus the C. For the C we will get 0 0 1 and it is 0. So our basis of W was what? So our basis of W is my, yeah, basis of W is my 1 0 0 minus 1 and my 0 1 0 0 and my, let me shift my screen. Okay, so the last entry is this. So we are using it in the lower case. In this case, we have to take the basis of W. So our basis of W is this. So what will we have? We will take my B. I want to write it with my red color. Yeah. So our B1 is my 100 minus 1. Yeah. So our B2 is my 0100, and my B3 is 0010. Okay. So the inner product of, I don't want to write it like this. Okay. So the inner product of AB1 is what? Then we will have only, now AB1 will be my A1100 and minus this. Okay, that will also be 0. That will be my 0. No, I am doing something wrong. Okay, leave it. So, firstly we are taking AB2. Then what we will get? Then we will get that our A12 is my 0. Then everything is nice. So now for our A, inner product of A, B3 is what? It gives us A21 equals to 0 for this point. And now for AB1, that is equals to my 0, and they all are 0. So from it we will have A11 is equals to my A2. So thus all the things will be what? So thus my matrix will look like alpha 0 0 alpha. That is my, we can say it our alpha I. So this process can be generalized to all n belongs to n. For all natural numbers, this process can be generalized. So this is my correct answer, I can think. Okay. Thank you guys. Hope you understood. Okay.